Welcome to the episode of the After Hours Project podcast. My name is Vardhan. Today we have Sham with us. Sham is lead for Team JNS. They make the CanSat. So he talks about what goes into making a CanSat, all the design considerations, what he learned, how he learned CAD, their experience in the US. Lot of interesting stuff, lot of interesting stories. What they're going to look forward to, where the team is heading, interesting engineering challenges, cool stuff coming up. Here's my conversation with Sham. Hello everyone, welcome to the After Hours Project podcast. Today I have Sham with me. Sham is the vice president of SEDS and also he leads the CanSat team at our college. So before I get into a lot of things, I think I'll just let him give a lot of the background. So what is CanSat? What is SEDS? Give us a background.
Okay, so SEDS is the aerospace club on campus on BITS Hyderabad. And Team JNS is the CanSat team, which is a part of SEDS. And we basically participate in this CanSat competition, which takes place in the US in Virginia annually. And we've been going to it for the past 3 years consecutively to the final rounds.
Wow. So what is a CanSat? Like, क्या होता है?
Okay, so a CanSat, it sounds like a satellite, but it isn't a satellite which, orbits the Earth or something. It is basically more like a planetary probe lander. So what basically happens is that they launch a rocket and from which the CanSat will be deployed. And our main objective is to make that CanSat land safely on the ground. And every year they adjust a few things in the project statement so that we have a different mission objective every time. So last time our mission objective was to protect the egg, and this time we have to make an autogyro mechanism.
What is an autogyro mechanism?
Okay, so an autogyro mechanism, it involves propellers, which basically help to reduce the terminal velocity of that probe. So this year we have to reduce the terminal velocity to 5 meters per second, and only using those propellers it has to reduce the terminal velocity.
And what is the max terminal velocity? So what does it start at?
So in these previous years, we have received the telemetry data from the competition. And so far, I think the maximum terminal velocity has reached about 30 meters per second.
30 meters per second. Yeah, from that you have to get it to 5.
Yes. And so there are actually two stages. So the first stage involves us deploying a parachute, which will reduce the terminal velocity to 20 meters per second. But then after that, we have to release a probe from the container. And the probe will have the autogyro mechanism attached to it. And that probe will further reduce the terminal velocity to 5 meters per second using the autogyro mechanism.
So that sounds like complicated stuff. We'll get more into it. But I want to get into a little bit more the background and inspiration of where all this started.
Okay.
So did you know about CanSats before? College में आके सुनने में लिखा.
I heard about it on campus. So actually, I was interested in joining SEDS in general because I was interested in aerospace from a long time.
Yeah.
And my branch is mechanical. So I was obviously oriented towards that direction as well. There's a rocket team called Artemis on campus. I initially wanted to join that actually because, rocket, they sound interesting and everything. But then I searched up all the teams and I found about Team JNS and I thought that is also quite interesting. So I thought I'll just apply for it. Let's see what happens. And I got into the team and then we have an enthusiast program. So they basically see that which of the inductees they're more enthusiastic about participating for the competition, how enthusiastic they're working towards this competition and everything. And I basically got into the team through that.
What did you start with? Like what was the role initially?
So I joined the structure subsystem. So over there, I basically design all the mechanisms which are involved in the CanSat. And I'm responsible for the structural integrity of the entire CanSat.
Yeah, bro, that sounds like again like interesting stuff, difficult also. But उसके बाद अच्छा, so you know कि there's different objectives for every time you do. What does not change? Well, there are things that change, so the objective changes. But what are things that are always standard? Every CanSat.
Standard thing is they always drop it from a certain height, and we have to reduce the terminal velocity in some or the other manner. So it is usually a parachute, or they leave it up to us. Like, for example, we also used a heat shield in the past, but this is something new actually. This year's project statement has been completely new for us because we haven't heard of an autogyro mechanism so far. So we had to research a lot about that. And we're making some progress on it.
Right, but I still don't understand what is an autogyro mechanism. Like, what is it supposed to do? What happens? Like, what does it deploy?
Okay, so the mechanism, it basically involves propellers, which would be on top of that probe. So a propeller, right?
Oh, but
Like in drones and stuff. So it basically relies on those propellers to generate some sort of drag to reduce the terminal velocity of that probe.
Got it. Acha, so, and like you can use one, you can use multiple, then leave it up to you.
Yeah, you can use multiple. It's up to you.
And so is there like a size limitation?
Yeah, there is a size limitation. So this year they have provided us the container dimensions and they provided us the model of the container as well. They want the container to be just like this. Usually they just provide us the dimensions and they want the container or the probe. So last year we just had a probe. We didn't have a container. So we just have to make the probe such that it fits in those dimensions. And other than that, we also have a mass limit. So we couldn't really exceed a certain mass.
Correct. So what kind of materials do you use if you have a mass limit?
So generally, for the mechanisms and stuff, we have to customize a lot of stuff. So we 3D print our components, and for that we use PLA generally.
Yeah. And then for the other stuff?
For the other stuff, so for structural integrity, we use carbon rods. So plates which have the mechanisms or the electrical components, such as the PCB or something like that, they'll be mounted onto those carbon rods.
Correct. And then how do you fabricate those, the carbon rod,
So the carbon rods are bought from outside.
most of us, I mean, there's no custom fabrication for that?
We don't have the facilities on campus to do that, right?
I mean, yes, yeah. It must be like very, very expensive.
Yeah, it is very expensive. It is also very difficult to deal with.
Yeah, I mean, dealing with 3D printing alone is, I think, one more tough.
Yeah.
So do you know, like, do you do some of this 3D printing or do you do any CAD designing and all?
Yes, so the past 2 years as a part of the team, I had done that. This year, I have more of a management position in the team. But I've still helped my juniors a lot with the technical aspects as well, because it is obviously quite difficult. And whatever knowledge I can pass on to them, it is always going to be helpful to them, as my seniors passed on to me as well.
And then did you learn 3D, like designing and all before college?
I learned it completely on campus. Actually, I didn't have an idea about CAD designing even before the inductions. Like, I got into that software just one day before the inductions, and I just came up with something. But they were really impressed with the enthusiasm which I showed. The rest of my batchmates showed. That is why we are a part of the team. Because the main thing over here is that we need to dedicate a lot of time and energy towards this. Like, there'll be many times when a lot of things don't work, but we still have to persist. We still have to go through that process.
Correct.
Like, we have to make a mechanism, test it out. If it doesn't work, we have to go back to square one. It is a quite lengthy process, but we can't really give up on it.
Correct. And so, so in your first 2 years, what were the problem statements? What did you make? Kya scene tha?
Okay, so in the first year, I wasn't officially part of the team.
Enthusiasm.
I was just helping them out. Yes. Yes, so that is an enthusiasm. I had to check it out, please.
Do you mind if I leave it in? If it can't be. This is super good.
So this is what can happen.
Restart it. Fine. Don't worry.
No, I don't have the files and stuff actually, so my junior will come and do it. It's fine.
Good.
Last 2 years, I was involved in the mechanism process and everything as well. So I was designing stuff on the CAD software. We generally use SolidWorks because it is quite a good software, to be honest. And then we 3D print the components and all that. So basically, I was involved in all that, designing, 3D printing, all that. Yeah.
And then how much time does it take normally out of your college life?
It depends. So to be very honest, our team was quite understaffed these past 2 years. Like, we generally have two subsystems, which is this structure subsystem and the avionics subsystem. The avionics subsystem, I mean, even they were sort of understaffed because we're just getting started a few years back. So we were figuring things out and stuff. So till my batch, it was quite difficult to deal with. And even my junior batch, they're entirely making the whole. So we have a particular type of PCB which we make, and they're making a different type of PCB this time, which is an STM PCB.
What do you do before? What are you doing now? Just a quick, like, easy level description.
So this PCB is basically more compact, and it is a bit more complex to deal with.
Okay.
So they're trying to come up with that one because it's obviously better. It's more efficient.
Got it. So you can reduce the size.
Yeah, it takes up lesser space and stuff.
Damn, bro. I mean, so you guys are like scaling up the projects now.
Yeah.
So your name is?
We have come up with a standard procedure for everything, but obviously we want to improve ourselves.
Correct.
So that is what we're doing.
I am just like blown away by all the stuff that you guys are doing. But okay, so you said your team was a little bit understaffed before.
Yeah. So what happens with the structure subsystem is that so far not many people have been interested on the mechanical side of it. Like many people apply for the electronic side of it, but many people haven't applied for the mechanical side of it. So far in our team, there have been only one or two members from each batch in the mechanical subsystem.
Yeah.
So yeah, it was quite understaffed. But I think in the 2024 batch, which is the freshman batch of this year, there are quite a few people who are interested in it. Like we have 9 enthusiasts this year.
Wow.
Because what we're doing is we're expanding. We're not just going for the US competition. We're also going for an Indian CanSat based competition. So we might distribute our team, or we're still looking into the logistics of that.
Bro, but like going from 1 to 9, I mean, I think 24 batch actually has been great. Like,
Yeah, you have been actually great.
insane participation and all the like smart people coming up. Acha, while you're on the topic of the teams, what is the so you think there are two two sub teams basically.
Yes.
So avionics and these structures.
Yeah.
Teams. So like, what is the structure like? Who leads what? How many people? What do they do? What are their roles and responsibilities?
Okay, so generally a third year student is the team lead who is in charge of the entire team.
So that is you this year, right?
Yes, this year it's me. And then under me, there are two subsystems, which is the structure subsystem and the avionics subsystem.
Yeah.
And the rest of the members are just divided into that. And I have other members from my batch who just mentor the whole process and everything.
Correct.
Like if my juniors, they need any help with anything, then they'll just come and help with that.
So avionics, what do they take care of?
Avionics, so basically there are three main things that they take care of. One is the PCB, which is the printed circuit board on which they will mount all the sensors and everything. Then they deal with two softwares, which is the flight software and the ground control software here.
And so you write it all yourself.
Yes, we have made everything in house.
Wow, that's amazing. Like I think Sanjay is a part of the, like he was a part of the team.
Sanjay, he had a great amount of contribution towards the GCS.
So wait,
And he did all that in his first year, which was quite impressive, I think.
yeah. So like, what does that do? What is the importance of that? Uska role kya hai?
So what happens is that the Yagi antenna which we use, it connects with the XB module on the CanSat, and it collects all the telemetry data from it, and we get it all on the GCS, which is the ground control software.
Okay, got it. So that is their role. So all the telemetry and control. So do you get to actually control the the CanSat? Like, do you do anything, any operation that communicates the other way, like ground to?
Yes, but generally we don't resort to that. We just want to collect all the telemetry data because they want the CanSat to be. Thank you. They want the CanSat to be like functioning by itself.
Yeah.
They don't want us to give us the direct orders to it, because there'll be a time gap, right? Between us communicating those orders to the CanSat.
Correct.
And the mission is quite small because
How long does it take? The whole drop thing?
I don't exactly remember, but
About
20 seconds.
20 seconds. So you put like an year's worth of work
Yeah.
into 20 seconds with a straddle set. That is insane. Like, those things are the most nerve-wracking things.
Yes.
To give, let's say you're a sprinter,
Yes.
100 meters, you practice 4 years for the Olympics.
Yeah.
9 seconds or something, done. Hey, you used to swim, right? I think,
Yeah.
do you still swim?
I mean, I am in the swim team, but I haven't been able to dedicate that much time towards that.
Fair enough. I mean, I think this has been taking a lot of your time, probably, Sure. Anyways, so the main, I think we debated a little bit. What were the main goals last 2 years? के लिए? Like, what are the objectives?
Hi, right. So during the first year, I'll just mention a few of the mechanisms which were involved. So one of the mission objective was that the probe should land straight on the ground. Then we also had to raise a flag by a certain height. I don't remember the exact height. It was at least 50 mm though, I think. And other than that, we had two separate components like this year. We had a container and a probe. So the probe had to be released from the container at a certain height. And yeah, I think that was pretty much it. And we had to attach a few cameras as well for like certain directions view. So that year, I think they wanted us to point the camera towards the downside.
Wow. So, like, how does that work though? Because you would have all the mechanisms to land it safely at the bottom as well.
So I actually dedicated a lot of time towards this because we had to have something which was transparent and strong.
That's what.
So that it doesn't break the camera while it lands. So we resorted to resin printing, which was again a completely different field for us.
Yeah.
Because we're dealing with 3D printing using PLA. Resin printing is slightly different. It uses a different type of machine and it is a different type of additive manufacturing process.
Correct.
So this is fused deposition mechanism, I think FTM. That is another different type of mechanism which is involved in that machine. And resin, so there's a material called clear resin, which can help us produce transparent or translucent 3D printed materials. So we had a small cap at the bottom for that. But in the end, it wasn't really that clear. So we resorted to having machined an acrylic rod so that we can make the cap out of that. So we use the CNC lathe machine in workshop for that.
Bro, I mean, it sounds ki ek step, do step, but I'm sure that must have been like hours and hours.
It was actually ours. I was one of the only freshman members who was active at that point in time.
Yeah.
So I had to continuously go to MEMS lab in New Acad block for that. And so what would happen is that they would print that component, and then I would have to apply a few layers of resin on top of that. Then they'll cure it using UV light. Yeah. So that will make it even more transparent. But that wasn't that effective in the end. But still, I had to do that for like 5-10 repetitions. And each time that thing happens, I mean, I had to wear gloves for the whole process because I couldn't touch the resin using my hands. So whenever I had to apply that, I had to wait for it to cure that one layer for 5 minutes. Then I had to take it out. I had to apply one more layer. Then wait another 5 minutes. Couldn't really do much in those 5 minutes, right? So yeah, we wait for hours over there just doing this.
Bro, insane. Like on top of all the college work that bitch has,
Yes.
you were doing all of this. Crazy, crazy. Acha.
So, but that is a good thing about BITS, right? We have so many clubs, we have so many departments and stuff that we learn to do things ourselves.
Correct.
Right? And we aren't just involved in academics, we're involved in a lot of other stuff as well. We don't have the 100%, I mean, we don't have an attendance system of sorts. I mean, it is quite difficult for a few branches because we have components such as supply spaces, like mechanical, for example. Yeah, I've been dealing with that since second year. It has been quite a pain.
ADM tutes, uske baad
Altitudes, uske baad.
bro, insane, like, crazy, crazy stuff.
Yeah.
But yeah, it is. Second year में क्या था?
Sorry?
Second year.
So second year I was basically involved more so in the designing aspect of it. ये सब grunt work freshman
Correct.
year में करते हैं.
But you need to learn all that, right? So that you know how to design that next year.
Also, I was involved mainly in the designing process, but again, I had to be involved quite a bit on the 3D printing end as well. So I was doing that as well.
Any specific challenges you remember from second year?
From second year, yeah. So I'll talk about this one release mechanism which we had to make. So we came up with like 3-4 different types of mechanisms, and even the avionics subsystem was involved in it because there were a lot of they showed a lot of interest from this side as well. Okay. So we came up with 3-4 different mechanisms. We tested it all out. And that year we were actually trying to print with a different type of material, which is called PETG. Because in the previous year, when my seniors went to the competition, they interacted with a lot of teams over there. And they suggested that we can use even PETG for our components.
What is PETG? What is the benefit over PLA?
I think PETG is more stronger. It is more sturdier. But the issue with PETG is that it has a high melting temperature.
Oh, so it's more difficult to work.
Yes. So the extruder temperature which we have to use for PETG, it often lies in the 230 degrees Celsius range. For PLA, it is often 210 to 215 degrees Celsius. Excuse me.
That's okay, don't worry.
So yeah, our printers don't print PETG that well. So that was the issue which we were facing. And on top of that, we were dealing with making so many types of mechanisms and stuff. So, and then the release mechanism, it had to be modified so many times. So one of the avionics members, they got an inspiration from a pressure cooker.
What was your name?
I think it was Kevin.
Kevin Cable.
So from a pressure cooker, he got the inspiration to make that release mechanism. But I edited it so that it is more, it has more weight optimization, and it is more efficient in general.
So what was the inspiration like? What did you end up designing? Can you talk about it, Jeff? Confidential, okay?
Yeah, I can talk about it. So we had a slot locking mechanism basically. So what that involves is that it has tabs on the shoulder, which was there, which was a part of the nose cone last year. And we have slots as a part of the main probe. So those slots, the tabs, they basically go into the slots and they lock it in. Basically, when that thing that rotates, it releases the heat shield. Got it. Which was the heat shield was also attached to the nose pump. So that was last year also we had two components, you can say.
Yeah.
It wasn't exactly a container and a probe.
Yeah.
It was more like a nose cone and the probe.
Damn. Okay. So, did you want to start making rockets, let's say, before you came into college, or like, let's say, CanSats, or did you want to get into mechanical designing, all of that stuff?
Yes, so I have been interested in mechanical engineering since the start. Like when I chose the science stream in around grade, I was pretty sure that I want to go into engineering and mechanical person because I wasn't a big fan of coding. Neither was I a big fan of dealing with circuits and stuff.
Yeah.
So, and I was thinking about during my bachelor's in aerospace itself, but aerospace doesn't have much scope in India, to be honest. And other than that, I thought if any other field interests me later on, it might be difficult to shift from aerospace to that field.
Correct.
So I thought I'll go with mechanical, which is sort of a core branch, and then I can later on specialize in whatever branch I want to.
So, what are the biggest challenges this year? Right. What have been?
Our biggest challenges this year. So as I said, the autogyro mechanism, it was completely new for us. We don't know how to go ahead with it. So we're just doing a lot of research on it. We're searching that which aerofoil shape which will be the most efficient to reduce the terminal velocity. I think we're conducting simulations and stuff for that, which we didn't have to compulsorily do in the previous years. Like we may do without the simulations as well. But this year it has been sort of a mandate that we have to do it. Other than that, so we're trying to employ last year's release mechanism in some way because that worked out pretty well for us. It worked out, worked out perfectly during the mission. So we want to employ that only this year. But this year the issue is that we have those propellers in the probe. So that those might interfere with the release mechanism. So we have to figure out a way in which those propellers, they don't interfere with that release mechanism.
And so, how do you simulate that? Like, what software do you use? And where do you learn all of this stuff? Like, let's say, this gyro mechanism. Oh, yes. Right. How do you learn about that? Like, what are the resources? And how do you learn about the simulations and all of that?
Yeah, so we just searched online about autogyro mechanism. Then we looked at a few YouTube videos. We looked at a few papers on Google. So we have a better idea of what an autogyro mechanism basically is.
Yeah.
Excuse me. So that, and yeah, what
about the simulations? What do you use?
Yeah, for simulations. So I haven't carried out any simulations myself so far because it wasn't required in the last 2 years. But my juniors, they are working with it, and I think they're using ANSYS for that.
ANSYS.
Yes.
I think ANSYS is difficult to work with. Like, I've heard people in mechanical. I think Rohan is doing some work with.
Okay.
Yeah.
Yeah, even I have a course called Principle of Aerodynamics, in which I have to deal with the simulation software. So I have a project in that, and we basically haven't decided what simulation software we want to use.
Yeah.
But we have to use one for that project.
Correct.
So I'm pretty sure it's going to be a big pain when we come to that.
What kind of data do you get? Like, what is the telemetry data like? What are the environmental measures? What do you look for flight stability, वगैरह?
Okay, so regarding the environment, so we have this environmental test which takes place before the competition. It is basically one round of the competition. So I'll explain all the rounds of the competition, so that is better. So the first round is the PDR round, which is the preliminary design review round. In that, we basically have to showcase 2 models to the judge, and we have to list down the pros and cons, and we have to explain why we chose the model that we chose.
Correct.
And basically what happens is this round is that it is the most difficult round for us. And we have been clearing that round the past 3 years, and which is why we have qualified for the final rounds of the competition. The reason why it is the most difficult round is that about 20 teams might be applying from India in any given year. And they only choose 2 teams to qualify for the final rounds. And teams like IIT, then there are a lot of private colleges as well, like DJ Sanvi. They have a really good team.
Yeah.
So
Last 2 years, who did you go with? From the other team from India?
So last year, it was Triple IT Hyderabad, which was the other team. But for 2 years before that, it was us and DJ Sangvi, I think. So we had been going continuously for those 2 years. And after COVID, the competition was a bit dull because, tech culture, it sort of
Took a hit.
took a hit.
Correct. You're talking about round. Sorry, I interrupted you. Continue. So, Oscar is preliminary. It's very difficult. 2 out of 20 teams are ish.
Yes.
Get snapped.
Then we have the critical design review.
Yeah.
Where we, it is sort of like PDA only.
Yeah.
But again, it's more like the final design review.
Correct.
After which we have the environmental test round.
Yeah.
During which we have to conduct a series of tests. So there are 4 main tests. One is the drop test, so that they can ensure that while the CanSat it is deployed from the rocket, there aren't any loose components.
Correct.
So we are supposed to attach it to one thread or a string or something, and we're supposed to drop it from about 1 meters.
Yeah.
And we have to ensure that no components of the CanSat they get loose and drop on the ground.
Acha.
Then there's the vibrations test, which is pretty self-explanatory. So it has to survive about 15 Gs of vibration force.
Wow. Bro, 15 G sounds like a lot.
Yeah. That is for about 10 seconds, I think.
But
10 seconds.
15 G.
Yeah.
How do you design for that? Like, uske liye, do you have to take any special measures? Like, if you didn't have that, what would you change?
Yeah, so we stick all our components together using epoxy or something.
Yeah.
So that none of the components get loose and they drop off or something.
Correct.
Right. Other than that, I think PLA has been a pretty good material.
How it is working well. Yeah. Is it inside a hollow? You have to look. What is it shaped like? Is it shaped like a cylinder? Is it like a cube?
Or CanSat?
Yeah.
Okay, so basically, it is a cylinder.
Yeah.
But it is quite empty in the middle.
Right.
Because as I mentioned, we use carbon rods for the structure's integrity, right?
Yeah.
So we have 6 carbon rods, which are arranged in a circular pattern.
Yeah.
And then on top of those, we have these plates.
Yeah.
On which we have all the mechanisms.
Correct.
So
It's
it is like
in the middle.
4 or 5 different plates on top of each other.
Like that.
And we just have those 6 carbon rods going around.
Got it. So it's like shelves, I say.
Yeah.
On each shelf you have some stuff. Got it. So we did. So after the critical design, critical review,
we have the environmental test.
Yeah.
So the other 2 tests which I want to mention were the thermal test.
Yeah.
And vacuum test. So what happens with the vacuum test is that there'll be a significant, not a significant pressure drop, but there'll be some sort of a pressure drop when the CanSat is at that altitude, right?
Correct.
So we have to simulate whether the CanSat works perfectly well in that pressure conditions as well.
Yeah.
And the thermal test is for if during the drop, the CanSat it heats up a bit.
Correct.
Then it has to still survive it. It has to be structurally intact.
Correct.
Right? So we usually heat it up to 60 degrees Celsius. And the problem with PLA has been in the past that it warps a bit if it goes to high temperatures like 70 degrees Celsius or 80 degrees Celsius.
Yeah.
So, so far it hasn't been an issue.
But yeah, it is a bit. Could be.
It could be.
That's why shipping to the PET material.
Yeah, we're thinking about it. But in hindsight, PLA has been the better material to deal with. At the moment, I think, given the current facilities and everything, PLA is the better choice to move ahead with.
Perfect. Acha. So those are the 4 things for environmental. Sorry, that is the 4 critical for the critical review. After that, the environmental test, right?
These were the 4 tests for the environmental test.
You got it.
Yeah. After that, we have the flight readiness review, which takes place over there, which again has a series of tests.
Yes.
So we conduct the drop test in front of them again.
Yeah.
And we have a few other tests, which I don't exactly recall. And after that, we have the main launch.
Yeah.
Which is generally about 40% to 50% of the entire score. After which we have the post-flight review.
Yeah.
In which we present our telemetry data and stuff. And we mention that the CanSat, if it survived, then it is perfectly intact or not.
Yeah.
And we show the camera recording as well.
So for the, let's talk about your experience in the US.
Yes.
So what was the score like? How do you guys perform? Kaisa tha?
So last year we had actually secured 100% in the PDR round.
Amazing.
Yeah. So that was pretty good. And I think only a few years back, probably MIT was the only team which has gotten 100% in the PDR round so far. So obviously we got 100%, so we are first. So we didn't have to worry about whether we'll qualify or not.
Wow, crazy.
And the second team, I think they lost only 2 points in the whole 230 marks or something. And the third team, which was DJ Sangri, which had been coming with us since 2 years.
Yeah.
They lost 3 points, I think.
Oh,
So
very
it was
close.
pretty cutthroat competition. It was pretty disappointing for them, I think.
Yeah. So yeah, that was the first round, and then
Yes.
uske baad,
So CDR round, it is mainly just a few things from the PDR round. We just studied it a bit and we get through that. We got about 98 or 99 in that, which wasn't an issue.
Yeah.
Then we had the environmental test. We lost a few points there because in the drop test, what happened was that when we released that CanSat, we had the thread attached to a rod. That rod, it bent a bit. So they were like, that might absorb some of the shock forces, which might
Pause.
which would have to be caused on the cancer during that test.
Correct.
So they were like, it isn't a perfectly complete test. So they cut a few points for that. Then flight readiness review also, it went perfectly well. The one issue which we faced in the flight readiness review was that we were using the walls of the rocket last year for the heat shield deployment. So what happened was that the heat shield, it had to deploy immediately after it was released from the rocket, right? So we used the walls of the container and we had those torsion springs which would automatically spring it open once it's out of the rocket. So it was a bit difficult to fit that inside the rocket. So that was one issue which we faced there. And then during the launch, everything worked out perfectly well at first.
Yeah.
Because the release mechanism worked well. And during the previous 2 years before that, not many things went our way.
Yeah.
Like a lot of our mechanisms failed, a parachute didn't deploy. Then, so last year, what happened was that we had carver rods and we had a resetting pin.
Yes.
So what happened was that we forgot that carver rods, they conduct electricity, which caused a sort of spark, and it made that reset pin on the PCB to keep resetting during that entire mission. So nothing worked that time. And that was pretty unfortunate because we put a great deal of dedication and effort into all the mechanisms which we had designed.
Correct.
But in the end, that happened and we couldn't really do anything about it. So last year, we removed the reset pin because obviously we don't want to deal with that again. So
Eliminated the problem.
yeah, eliminated the problem. And and then we got our model and then we had to show the egg intact in front of the judges. We had to open it up in front of them. Open it up, and unfortunately, it had broken. And the most unfortunate thing for us was that the 70 teams which were ranked ahead of us, all of them had the egg intact. And that was a major chunk of the entire score.
Correct.
So, and another thing was that we put so much effort into the release mechanism.
Yeah.
But later on, we found out that during the launch mission, there were no points dedicated towards that release mechanism. So, I mean, I couldn't really blame them as well because they provided us a score sheet quite a while back.
Yeah.
And we didn't notice that the release mechanism didn't have any points in the score sheet. But normally, obviously, in the mission guide, if it was mentioned, we would obviously make it perfect.
Yeah.
So this year, obviously, we're looking into that nothing in the score sheet has been missed out from us.
Correct.
And we'll dedicate more time towards those things which have more points.
Right. So what it sounds like is you came 18.
Yeah.
And so you were the top amongst all the teams and jinka 8 to neck to tha, right? That is still crazy. Like
I think we might have been first among all the teams jinka ek tuta.
That's what. Like so
because we got 100% in the PDR.
Yeah.
And even after that, in most of the rounds, we had almost scored perfect.
Wow, bro. Like how does this like even come about? Like how's the culture still maintained? Like what are the seniors doing right? What do you think you want to carry forward the same thing?
Okay, so the person who started this whole team, and they had started the team in 2014, but the guy who gave this team the boost which it required to go for the competition, go and perform there, that was Anand Kumar Dasur, who was the team lead 3 years back.
Yeah.
After that, there was Pratyush Gupta, and after that, that was Anmol Panandab, who was my predecessor.
Got it.
So, he basically put in a lot of effort that no matter what, we want to go for the competition. जैसा भी बने CanSat. तो फिर वो साल तो weight limit तो कुछ ज़्यादा exceed हो गई. Because I think they made the CanSat out of metal, aluminum or something.
Yeah.
And it obviously has a high density. तो फिर उसका तो weight कुछ ज़्यादा ही हो गया था.
Yeah.
But at least they went for the competition. So that was a major motivation. Ki we want to go for the competition no matter what.
Correct.
So we at least get that PDR round done perfectly. And I think what Pratyush Bhaiya did was that he got that PDR round perfectly executed. I mean, we did lose a few points that year, but last year during Anmol Vyas tenure, we got that 100% finally.
Correct.
So then what we had to deal with was that we don't have any problems during the launch.
Yeah.
So like that reset pin, right? So Anmol, we ensured that, we don't face those problems and everything. And we generally have a really good bond in the team in general, because we are a pretty small team, right?
Correct.
We have only about 5 members from each batch so far. Only this batch will be an exception because now we are expanding. We're going for 2 competitions, as I earlier mentioned, right? So, it has been a pretty good bond. Like, we fight. It's not like senior, junior. It's more like we're all friends, right? Like, I have the senior called Vigno.
Oh.
I used to have chalk fights with him and stuff during all our meetings. It was pretty fun.
Yeah. It sounds like it's an environment to have the best ideas been. Right? That is what is most important.
Yeah.
So,
Like, more than work, we play around. So I remember during my first year.
Yeah.
So me, Anmol, and Pratyush, we used to spend so many nights in Sandbox.
Yeah.
Like, during that time, we were figuring out the whole 3D printing process.
Yeah.
Because as I mentioned, during Anand's time, they went with metal components. So obviously, we wanted a more lightweight option.
Yeah.
So we are going to resort to 3D printing from that year onwards. So we weren't exactly that expert, that big good experts in 3D printing. So figuring that whole thing out, we used to spend entire nights here. We used to continuously monitor the whole process and everything. So,
crazy, why? Have you slept here?
Yeah, many times. I remember at least 3 times I've slept here. And then one night we even walked around R&D. We used to have a lot of fun.
Bro, amazing culture, like,
Yeah.
crazy stuff.
Because at that point in time, we had end time, right?
Yeah.
We had an end time of 2 a.m. So after 2 a.m., we can't enter the hostel. So we're like, it's fine. We don't want to, rush back to hostel. We'll just sleep here. We'll do something. So sometimes, fortunately, a few of the classrooms were open. So we would go and get to sleep in the classrooms. So otherwise, we had a few beanbags there before. But I don't know what happened to those beanbags.
No, crazy, like insane dedication. But I think we're talking about the data that comes back, the telemetry data.
Yeah, telemetry data.
So, like, what data do you get back?
So we have a few sensors. We have a temperature sensor. We have a pressure sensor.
Yeah.
Then we have a rotation sensor as well.
Yeah.
So we get the rotation data, right? What is the angle by which it's rotating on each axis, X, Y, and Z.
Yeah.
Then we get the temperature data. But then from the pressure sensor, we can also calculate the altitude. What else do we have? Then we have a microcontroller, which, generally controls each and everything.
Yeah.
Then we have the XB, which is the communication module, as I earlier mentioned.
And so do you buy that? Do you make that? Like what is that?
So we buy all of that.
Yeah.
I mean, making a sensor would be too difficult. That is quite an expert task. I think none of us are equipped for that at this stage.
Yeah.
And then obviously we have the cameras.
Yeah.
So yeah, that is pretty much it.
Correct. I mean, expertise and time constraint, like if you had 2-3 years, you could probably
we can
figure something out. But like, so I want to talk a little bit about how you got into CAD and how you joined it. Like, so more as a recommendation, more mentors, more YouTube. Look, what was the mix like?
So for the induction problem statement before getting into JNS, I went on YouTube. I searched a bit about CAD and stuff.
Yeah.
Then the big issue that I had was that I had a MacBook, so I couldn't install SolidWorks on that. So I had to get a new laptop. And I mean, my dad got it for me happily because he anyways wanted a laptop change. So he took my laptop and just gifted me a new Windows laptop.
Yeah.
Then I got SolidWorks onto that.
Yeah.
But I majorly learned SolidWorks during my second year.
Yeah.
Because during my first year, I had the MacBook. So during my first year, I used to deal with all the manufacturing process and everything. That was pretty much it during my first year. So during my second year, I used to get some help from Anmol and Pratyush for the CAD thing. Pratyush wasn't there much because he obviously was in fourth year.
Yeah.
But Anmol helped me out a lot. And then we have a great YouTube playlist for SolidWorks as well.
Yeah.
So I learned most of SolidWorks in that.
And then, so now you're confident with SolidWorks?
Yeah, I'm pretty confident with SolidWorks. Like, even if you want me to manufacture anything, basically, I'm just choose any complex thing.
No, that is such a great
skill. I can handle. I think I can design it on CAD.
But like, how many people coming out of college can say that? Itna confidence on us.
I'm pretty confident that every JRS member can say, yeah.
Good pitch for the club. So most of these, so Anmol Bhaiya, Pratish Bhaiya, are they from the structures team? Are they from the avionics team?
Yeah, so Anand Bhaiya was from the electronics team.
Right.
Then Pratish Bhaiya was from the structures team. Anmol Bhaiya as well from the structures team. And I'm again from the structures subsystem.
Right. Acha, ठीक है. And like, what did you learn? Like, halfway, जो बाकी teams थी, you said you learned that you could use PET.
Yeah.
What are the other things? Like, what are the like big learnings?
So we got that torsion spring mechanism idea from another team as well.
Yeah.
So I'm not exactly sure where they got that inspiration from.
Yeah.
But Anwar Bhaiya was like, I have an idea for this, and we'll go ahead with this only because I think this will work perfectly.
Yeah.
So we made that. We were like, how we don't want to mess around with this. This is working perfectly fine. So we dedicated our time and efforts towards other stuff, other mechanisms.
Correct. Okay. So, you have any specific advice for students getting into the CanSat team, like first year right skill? Like, what do you think, tell them on the first day? Ki aisa karna, aisa karna.
See, to be honest, as I mentioned, I also didn't know anything about CanSat before. I learned from ground zero. So we don't have any prerequisites per se. It's just about time and dedication.
Correct.
Like, if you're in another technical team, I don't want to be like that because I myself have been in another technical team. I've been in Team Vulcan in SAE. So it gets quite hectic to deal with both teams. At that point in time, Janus was on the staff, as I mentioned. So I had to carry a lot of the workload here. I think it will be easier for batches from 2024 because they have quite a few people interested in this field.
Yeah.
But again, that's the thing that they have to sort out that time management and stuff.
That is the biggest thing.
That is the biggest thing, James.
So how do you programming is something called Git for working with other people. So for SolidWorks, you just send the file key. This is what I've done. You work from here. Is there a way to collaborate?
So basically, we create a OneDrive folder on Microsoft Teams, and then we get all the real life, changes done at that point in time. So whatever changes I've done, my teammates can look into that at that point in time itself and work on it. The only thing is that we shouldn't be working on the same file at the same time.
Right.
That is the only issue. Baki sab theek hai.
Baki sab theek. All right, got it. I was just a little bit curious about that. Anyways, we follow along with space news. Yeah, or any space news ki this is what this company is doing or this is what is launched or NASA, anything like that?
So I mean, I follow SpaceX a bit, NASA a bit. So NASA is going for that moon mission soon. Artemis, which is again like Team Artemis.
I think I saw recently
SpaceX, they caught that rocket midair.
Yeah.
That was pretty impressive. But yeah, that was pretty.
I think they also got like the most number of satellites by any company or entity or something like that. There's, interesting stuff happening. So let's say you come up with अच्छा ठीक है ऐसे हमको ये mechanisms बनाने हैं. So what is the whole process like from the conceptualization to the last final competition day?
Yeah.
Like what does the structure go through? What is the life cycle of a structure?
Okay, so I'll explain it for the structure subsystem first. Okay. So we read the mission guide and everything. We go through the whole thing. We list down all the mechanisms, the main mechanisms which are to be made. So this here, for example, we have the release mechanism, we have the auto-guided mechanism, and we don't really have to make a parachute mechanism per se because they want the parachute to immediately open after. So what we usually do is that we ensure that the whole CanSat, it has a low center of mass so that it is dipping towards the side as well.
Yeah.
So the parachute side is above, and the parachute, it will have a lower density. So it will automatically inflate and then it will, open up properly. So how we list down all the mechanisms. We list down what sort of mechanism we can make for each mechanism. We do that as a team.
Yeah.
One guy suggested this, then the other guy suggested that. Then we'll discuss all the pros and cons of everything as is required from the PDR. Okay? So how we do that, then we choose a few mechanisms which we want to test out. Like for the auto-guided mechanism, I think my junior Gayatri, she has made one mechanism for that. And one 2024 batch enthusiast, he has made another mechanism. So we'll test out both mechanisms, which we'll see which one works better. And then we'll go ahead with that one.
Correct.
Yeah, so
brainstorming,
figuring out. And the major issue again is that all the mechanisms, they need to work together.
Yeah.
As I mentioned, that the release mechanism, it might have an issue this year because they might interfere with the propellers, which would come into the probe. Okay? So we have to put it together on CAD. We have to see whenever all the mechanisms they're working, is it colliding with something? Is it interfering with something? So we might have to modify that mechanism, or we might have to go ahead with another mechanism accordingly. And yeah, that's pretty much it on the structure side. Then for avionics, so avionics, Sanjay had started the whole GCS thing.
Yeah.
I think Vigno and Alan must have helped them at that point in time as well. I'm not exactly sure about it. Then PCB, I'm pretty sure that Umang has done that whole thing from scratch from first year.
Crazy.
So that was pretty impressive on his end.
Yeah.
And then FSW is there.
What is that?
Right? Which is the flight software.
Oh, flight software. Okay.
So I think everyone has worked a bit on it.
So that is the calibration software. What is that?
I think that is mainly involved for all the coding and stuff.
Got it.
Mechanisms वगैरह कब deploy करना है, sensors वगैरह आपको code के जो भी है, PCB में जो भी coding जाए.
Okay, so the integration of all the electronics and
Yeah.
what the fact. Got it. And so I'm guessing the integration hell is real for you guys. Matlab,
Sir.
integration hell. Matlab, I'm putting everything together, the electronics, the structures. Like that must be a crazy process for you guys. Acha, abhi suppose after you design it, after you do all that, like is there any dry run that you do? Do you drop it? Do you tell it?
So last year was the first time that we were able to drop test a mechanism.
Yeah.
And what we did last year was that we didn't have the entire CanSat assembled, but we had a few components from the CanSat assembled. So we made a mini CanSat of sorts. We had the PCB on top of it, so we can test out all the sensors. Because last year we had a pitted tube sensor, which was used for calculating the airspeed. So Umang and everyone, they were very unsure about how that is going to work and everything. And they had tried a lot of methods to get it to collect some data, because it required a certain amount of air to go into it before it shows a reading.
Right.
So they tried using the fan and stuff, but it didn't work out. So we tried dropping it. Then finally we got some reading after some point in time. So we made that mini CanSat configuration for that. Then we tested out the release mechanisms separately. And so what happened was that it's actually funny because 2 years back, we were testing out just the parachute. मतलब parachute को bottle के साथ या किसी के साथ भी फेंक रहे थे. We were seeing that it opens up. बस खुलना चाहिए. ठीक है. Then last year what we were doing was that we were throwing the parachute along with the parachute release mechanism. कि parachute का वो जो lid भी है वो जब खुल रहा है तब release हो रहा है parachute या नहीं हो रहा. And is it releasing in the duration that we want it to release? So before NeoCAD, it didn't have closed staircases like now, right? So we're able to do it over there. We used to just drop it, and so we also had to figure out how to fold the parachute, which would be the most effective way, so that it opens up as early as possible. So our parachute mechanism last year, it had basically it had a base, it had a circular wall around it, then it had a lid on top. So we expected that whenever the lid opens up, the parachute will come out and it will open up, right? But what happened was that the parachute was too big and the parachute bait was a bit too small probably. So it took some time to come out of it. Thoda tight ho jata. ठीक है. So we thought about removing the walls along with the lid. So we manufactured the lid in that way.
Oh, that's interesting.
But then another issue with that was that uska center of mass thoda aisa आगे पीछे हो जाता है. So we did one thing. We just scrapped the whole lid idea. We went ahead with a simple rubber band. कि rubber band से इसको lock कर लेंगे. Rubber band जब खुल जाएगा, तो parachute भी खुल जाएगा.
Bro, that's crazy.
And that worked out perfectly fine.
So how do you come up with that? How do you come up with that? कि rubber band use करेंगे ऐसे?
I think Anmol had seen it somewhere. He just suggested that.
Oh, I mean, I'm guessing the center of gravity is off because of the way you fold the parachute.
What happened was that वो lid थोड़ा बड़ा हो जाता था. जब balls के साथ हम निकाल रहे थे. उसके center of mass थोड़ा आगे पीछे हो जाता. Like so for that too, parachute फिर भी थोड़ा tight रहता था उसके अंदर. So it was a better idea to just remove the walls altogether.
I think one thing I'm seeing as a trend is कि whatever goes wrong, you just remove it, figure out like
Yeah.
either replace.
We don't want to deal with it. बस हो गया भाई इसका.
I mean, see, one thing that I see with a lot of college teams ka problem is that you only have 1 year and effectively 3 years to make any sort of thing that you want to make. It's in first year, you're doing a lot of the grunt work, you're learning how the things work.
Yes.
Right. Second year, third year is when you actually can, design, like do a lot of the decisions. I'm guessing that's how.
So mostly all the second yearites work in our team.
Yeah.
Third yearites, they're just mainly involved in mentoring the team.
Got it.
Because except for the team lead, all the other third year students, they also involved a lot in academics and stuff.
Correct.
They probably are another team in which they are also helping out.
Yeah.
So they probably aren't able to dedicate that much time on the photo.
Fair. I mean, so the problem with that, I think, is that you can't do like massive changes in your tenure. because you have to make like a 1 year, two things you can fix, maybe one incremental change. But again, maybe a step change also. Like I think you guys made like good step changes over the next last 3 years. You went from not getting in to getting in, then getting 100, and now let's say the point is only
that top prize. We're counting on it. Last year, we were actually hoping to get at least into top 5.
Yeah.
But unfortunately, the egg broke. That was pretty unfortunate. We were all pretty disappointed. They were just like, में गया लास्ट नाइट यूएस में एंजॉय करता है मैं तो मतलब रुकने वाला था because I have relatives over there.
Right.
I was going to stay with them for a while. I was going to travel around US. But I mean, I think Umang, he was leaving that day. And Anmol and Alan, 21 batch.
Yeah, go ahead.
They're also leaving that day. So we just wanted to enjoy that last night over there.
Was fun as ekdam.
It was fun.
Bro, nice. And like, what sort of team participate? Like, so you said MIT. Are there teams from other countries like Germany or?
Yeah.
क्या होता है?
I mean, MIT hasn't participated in a while, I think.
Yeah.
So last year, I think the first team, the first ranked team, it was from Poland, I think. And that is where we got that PCB idea.
Right.
कि SMD PCB बनाते हैं अब, because that is very compact and stuff. And actually, all the other teams, they're majorly all graduate students or PhD students.
Acha. Oh, so you guys are like one of the few
One of the few undergraduate students who are going over there, undergraduate student team.
It's crazy, man. That's what see, this is one of the reasons I wanted to do this is because I wanted to learn. And like, this is crazy stuff. You guys are competing with graduates and PhDs, and this is all happening on campus, and a lot of people don't even know about it. Like, crazy challenges. But I'm guessing, because you work on structures, not a lot of the software, you would have a lot of information about this. Yeah, so I think you can go let that be like. जब power considerations होते हैं कुछ, like, do you have to account for power efficiencies or you only have that much? क्या होता है मतलब? What is that? उससे क्या scene होता है?
Obviously, we try to reduce the amount of motors used or servo motors used and DC motors used and everything, because we have a certain power. I mean, we have only a limited amount of batteries which we can include in the model.
Yeah.
Like each battery, it will weigh almost 50 grams. So if you want to include another battery, then we might have to decrease the infill for our prints, which will again decrease the structural integrity of it.
Correct.
So we try to make our mechanisms mostly automated. Like they don't need to use that many servos and stuff, servo motors. So we mainly use servo motors for all our mechanisms, right? So we try to eliminate the need for that.
So do you have to work with electronic batteries only, because that is like static weight, right? Or like do all teams use electronics?
Yeah.
Or is there like one of the fuel sources that you can use? This may the weight decreases as you go on. But I think that's probably like a more difficult thing to get into them.
You're talking about using a fuel, like
Yeah, actually no, that would reduce the weight as you use it, but like I'm guessing that doesn't make that.
Again, it is an explosive, and I don't think we can use an explosive.
That'd be crazy. Like imagine someone just comes with rocket fuel to the competition. Achha, it has to end safely. So like, uska kya hota hai? What does the mechanism look like for that? Because I mean, I'm seeing all these companies land their rockets now.
Yeah.
So, but you guys do it as well.
So 2 years back, we had to land it straight on the ground, right?
Yeah.
So we used a spider leg sort of thing for that. I'll show you the photo if I have it. Last year, we didn't exactly take weight into account that much.
Everything was metal. Just wanted to get the preliminary round through.
No. Last year, we did want to, perform well. But our weight optimization wasn't that on point.
Right.
Like we weren't checking what infill we should use for everything. We just used 100% for everything. And we ended up using Kevlar to cover up the CanSat to protect it. And Kevlar is very strong. It is like bulletproof and stuff, but it is also very heavy. So we exceeded the weight limit by a great amount. I think it was by about 600 grams or something.
And what is the weight limit?
I think it was 800 grams that year. And our model was weighing around 1.4 kilograms. I think. We lost quite a few points there. So last year, I ensured that, our weight optimization should be on point. So I created a mass budget from the beginning. I wrote down the mass for each and everything. कि इतने infill पे इतना mass होगा. And I ensured that, mass तो कम होना ही चाहिए.
Correct.
So I ensured that the mass was about 800 to 820 grams last year.
Yeah.
Even though the limit was 900 grams last year.
Oh, so you're under, like, crazy.
because later on, if you want to increase it, we can just increase the infill and get it done easily.
Yeah.
But reducing it is quite a task.
Correct.
So I carved out holes and stuff in the plates as well. जहाँ पर भी reduce हो रहा है करना है.
Wow, bro. Okay, yeah. And that is not a thing something that I would have thought about. You have to do those kind of things.
हाँ, मतलब जुगाड़ी है ये जुगा मेरा.
Abhi, what is like the biggest limiting factor right now? If you had this one thing, it would take you to the next level. Abhi ki stage pe.
I think the propeller design. We are finding it a bit difficult at the moment to come up with a good propeller design.
So वो propellers, so there'll be motors driving it, या फिर वो गिरते गिरते जो speed से like.
वो गिरते गिरते जो speed से जा रहा है उसी के हिसाब से.
Okay, it has to work on that. Okay. And then is the size like, can you make the propeller like this wide, or does it have to fit it in the?
It has to fit in the rocket
Yeah.
body, right?
Correct.
In the container per se, because this time the probe goes into the container.
No, can it expand after you deploy?
It can. So we're trying to figure out a way to do that exactly.
Bro, but like working with solids and doing that will be like some crazy stuff.
Yeah.
Pata hai kya, but like, are there like flexible designs possible? Like,
So I mean, we're thinking about having hinges in the propeller and stuff, but we're still figuring it all out. We're not exactly sure how we'll proceed.
how long you are? When is the competition?
So the PD around it, it has its deadline in January end, January 31st, I think. So by then we at least need to have the design ready. And just in case the judges have any questions for us and stuff, we want to test out everything beforehand.
Correct.
If they question us for this, then we'll tell them, we have tested it out and we're pretty sure that this works perfectly fine. Like last year, what happened was that in the PD round, they didn't have any questions.
Yeah.
That is why we got that 100%. But then in the CD round, they're like that, how will you ensure that the battery connections don't get loose? So we told them that we'll, secure it using epoxy and stuff. But they weren't completely convinced with our answer. So I think they cut a few points there.
What is the right answer for that?
I'm not exactly sure. But in the end, we ended up using straws in the middle.
Huh.
And I think that worked out better.
Wow.
Because on top of the epoxy, it also has those straws to, keep that distance the same between each and every plate. Right.
Okay. That's something I got it. Okay. So abhi, so that the biggest limitation is the propeller design for you right now.
Yes.
And so budget is that ever an issue? Like, do you run into financial constraints? You have people understand this one thing you said. It's like if you had more people, could you do more designs, iterations?
Yeah, so that is what is happening this year, right? Like we have way too many people. I mean, not way too many. We have a decent amount of people this year. So we can, think about more mechanisms, more different type of mechanisms. We can test them out as well. And we are trying to go for 2 competitions as well, as I mentioned.
Correct. Yeah. So one in India. Where is that?
That is going to happen in December. It will mostly happen in Bangalore, I think.
Right.
So not this year, December.
Like next year, December.
Yeah.
Okay, got it. So the rounds will start this year only.
Yeah. We submitted the PDF for that in September end, I think. So Murat वगैरह देख के. Because last year that we did that for PDR.
Really?
For the US CanSat.
Wow.
And we think that is why we got that 100%. So we don't really want to jinx that. Murat वगैरह देख के करना है अब जो.
Wow, bro. I mean, I've heard like the space agencies and all also have like some small superstitions. So I guess this could be like your little, superstition, I guess. And like, do you just like suppose let's say you want to flight in the US, in some city, they might have different weather conditions like temperature, and all those sort of things. So do you like look at the weather report to say after like what is the weather like there, all those things? Is that a consideration after the CanSat?
I mean, in general, we are on Earth, so the environmental conditions, they don't vary that much.
Right.
So I mean,
it's
primarily, yeah.
Acha, fine. Fair enough. Acha, so like last question. Where do you want the team to go next? Last, that's it. Where do you want the team to go, from here next 2, 3, 4 years? Like, where would you like to see them? What are you telling your juniors? वो तो रात में बात है कि यार ऐसा हो तो बहुत सही होगा. So what is that?
So obviously the goal for this year is that we want that first position. But before that, we obviously need 100% on the PDR.
Yeah.
Because that will be then a sure thing that we are going for the competition. There is no way that we are not being qualified for it.
Correct.
Because obviously nobody can get more than 100%.
Yes.
So after that, obviously you want to win the competition. So after that, what we're going to do is that we're just going to carry out as many tests as we can so that we can ensure that nothing fails in the whole CanSat.
Got it.
Because last year, we did carry out a decent amount of tests. We checked that at that terminal velocity. So the terminal velocity, when it reaches the ground, it was supposed to be 5 meters per second.
Yeah.
So we, just calculate from what height the velocity will reach 5 meters per second. Then we dropped it from that height using that root 2gh equation height. And yeah, it survived the fall. Then we, double that. We checked for 10 meters per second now. I think it broke then. But we were like, hopefully, the parachute works perfectly and 5 meters per second pe ho jaye. Because you wanted to also focus on the release mechanism.
Correct.
So, I mean, the goal for this year is that we'll carry out more tests. We'll ensure that whatever we're doing is absolutely perfect. And we want that first position.
Yeah.
And in the coming years, I think we want to expand the team, as I mentioned. Like, we're going for the Indian CanSat team Indian CanSat competition as well. So we would obviously want to get a first position there as well.
Yeah.
And I have a few other things in mind, but we're still looking toward that.
I want to disclose that. Fair enough. And is there like things that you want to work on? So let's say you're interested in aerospace. Yeah. So are there like are there companies that you want to join, or are there projects that you want to take on? Like, is there like this is what I want to do with all this shit?
So right now I'm working on a few projects under a few professors, which involves a lot of smart materials.
Yeah.
So there's this material called nitinol, which is a shape memory alloy.
Yeah.
So what happens is that in solid state, it exists in two different states, which is the martensite phase and the austenite phase. So in austenite phase, it exhibits a property which is called superelasticity. So even if you bend it or something, it will return to its original configuration.
Crazy. Yeah.
So I'm dealing with mechanisms which can use that and eliminate the need for any different type of mechanisms which will involve more weight or which might be more risky. Like, there are a few gunpowder mechanisms for stuff like parachute release, right? So maybe just for an example, like I would want to design a parachute ejection mechanism which just uses nitinol for it. Then another thing is that a few mechanisms, they use a lot of very heavy motors. And whenever you're sending something to space, obviously you would want to keep it lightweight.
Correct.
Because how much of a heavy that thing is, you need to use more fuel to send it above.
Correct.
And we want to cut costs there. That is the general idea in the aerospace industry.
Yeah.
So I'm working on those sort of mechanisms under a few professors, mainly Amit Kumar Gupta sir.
Amit Kumar Gupta. Yeah. Acha, is this nitinol the same thing that I saw? Like, basically, it comes back to the same shape. I saw like NASA is using it.
Yeah, it is using in the Mars rover tires, if you have seen it.
Right. I think that's what I picked it up. Anyways, are there things outside of Janus that you're working on, or anything like the projects that you mentioned? That is one thing.
Yes.
Uske alawa kuch hai? Like that things that you would like to talk about?
Uske alawa, mainly I'm trying to focus on my cats. Because anyways, being a part of JNS itself, being the lead for that, it is already a pretty hectic task.
Correct.
Then just before Atmos, because I'm a PR in SEDS as well,
correct,
I was quite occupied with that as well.
What all did you with the work just nice? Like what was?
So we had 4 workshops and we had a competition as well.
Yeah.
So we had an egg drop competition, quite ironic. Yeah.
So who won? What was the design?
So one of my juniors actually won from the JNS enthusiast.
Okay.
So the design is right here actually.
Damn.
If you want to have a look at it. The egg actually broke later on.
Oh, so
because we were playing with it and we just wanted to see that how hard we throw it and it breaks.
Right.
And it finally broke.
Wow. So
yeah,
what is the mechanism inside?
They just use these straws to, I think, absorb the blow. And they have a lot of polystyrene beads inside, I think, and a lot of foam.
So what is the? So I think weight was probably one of the considerations that you guys took. What is the consideration?
So I actually just gave them dimension constraints.
Acha, that's it.
I didn't want to make it too tough for the students.
Right. And that's how
I wanted to basically have as many people participate as they can.
Correct.
So for this, that was it.
Okay, uske alawa, what all other things?
Uske alawa, so JNS had 2 workshops. One was in collaboration with Artemis, which is the rocket team, right? So that was a rocket designing workshop in which we had 3 softwares.
Yeah.
We had OpenRocket on the first day. Second day, it was a CAD software, which I had conducted.
Yeah.
And on the third day, we had taught them ANSYS, which is the simulation software, as you know. Then we had a circuit fabrication workshop, which has worked pretty well these past 2 years. I think Umang has started that during Tech Week in our first year. That was actually pretty good because he thought about it in first year itself. we got a pretty decent turnout in something like Tech Week.
Really?
We had about 40 people show up for it.
Wow.
And last year we had about 100 people show up for it.
100 people?
Yes.
Wow. Yeah.
And then we have 2 more workshops this year from SEDS. One was done by Hyperion, which was the workshop was named Equilibria, which was basically a PID workshop. And then we had one more workshop from Archangel, which was the Candy Thrust workshop.
Right, what is that?
So they basically made sugar rockets in it.
Oh,
And then they carried out static test of it on NFG,
Right.
U4 World Run.
wow. So apart from SEDS, so what all departments and things that you do? Yeah, seen it.
Okay, so I'm in DOPE, which is Department of Professional Events. So when I came on campus, obviously there was so much hype around DOPE. I think you remember.
Yeah.
So I applied for it.
Hmm.
Unfortunately, I got in.
Yeah.
So that was pretty fun. I mean, you deal with so many different artists. You deal with some very hectic jobs as well.
Yeah.
Like you might have to figure out at the end moment that ये artist के लिए ये कहाँ से लाना है या जो भी artist को चाहे, we need to manage it somehow.
Correct.
Like, and then we also have a lot of other BT, ये सब cabs वगैरह का.
Wow.
So that is all a lot of stuff to deal with. And we are a pretty small department.
Correct.
We have only about 10 people from each batch.
DOPE is very difficult to get in. Like I remember a lot of people apply,
Yeah.
very few people get in. What is the induction process like, Scott?
So yeah, the first round is basically a one-on-one interview. They ask us a few basic questions कि ये situation में क्या करोगे या फिर जो भी हो. Then second round, I think we have to make the lineup. कि इतने बजट में से क्या क्या artists लाओगे. So basically that is to test our artist research. And then in the third year, we have to defend our lineup. Why did we choose this over that or whatever? And how did we fall into this budget bracket? How did we estimate the prices for the artists? Because no student has the access to all those prices, right? So what I did in my year was that I basically went on Spotify, I saw all the monthly listeners and just estimated based on that.
Yeah.
Because I think it was just 1 month on campus. So they weren't going to be that tough on us.
Yeah.
We don't expect you to know everything. Even if you know a decent amount, that's fine. And then in the fifth round, it was the GD, which is the group discussion.
Yeah.
So we have, they divide us into 2 groups. They give us a topic each. And then we have to defend whatever that is. Like we have stage 1 and stage 2 on campus. So one of the questions over there was, why would you choose stage 1 over stage 2? And why would you choose stage 2 over stage 1?
Yeah.
Something like that. It has been quite a while since I've done dope work. So I have to really rattle my brains to remember all that.
Yeah. So third year, so now a lot of your time goes into dope work, or is it just mostly?
No, so first year I worked a lot in dope. I loved the work as well. But in second year, I was, more dedicated towards JNS and SEDS as well. So during Atmos, I was quite busy with all the workshops and stuff that we had, which SEDS had. And, excuse me. So both the workshops which happened last year were conducted by JNS and US, my batchmates.
Yeah.
So I went to help them out a lot with that. And then during Pearl, I was there during Pearl for dope, most of the time. I went for Sunidhi's pickup and Shreya's pickup.
Wow. So you ever talked to them?
No, I didn't get to talk with them, unfortunately, because the manager was quite stingy about that. But yeah, it was fun.
Yeah,
we went to Novotel, we handled all the, room bookings and everything.
Wow. I mean, so have you wanted to interact with any of the artists as a backstage or anything? Any fun experience, basically, what I'm asking.
I think in Atmos in first year, I had interacted with a few. Others, I've interacted with a lot of the crew and stuff.
Yeah.
It has been quite fun.
Yeah.
I interacted with the manager as well a lot. I interacted a lot with the Spectral manager. I don't remember his name. I think it was Saurabh. It was quite fun with him. He's a pretty chill dude.
So any fun moments that you remember from your work at Dope or anything to that sort? Like any stories that you yaad I know thought difficult on spot dala to yeah. But still, if you remember anything, we could talk about those things as well.
Okay, yeah. So I'll talk about Pearl last year.
Huh.
So what happened during Pearl was that Sunidhi Chauhan left in her Maybach. Sunidhi, or I think it was Shreya. Yeah, Shreya left in a Maybach. And her artist was artist manager was left behind at the hotel. Then he comes downstairs. He's like, where did Shreya go? And then he panics a lot. And then me and Akshay Arjun, you know him as well, right? So we both were trying to calm him down. We were like, we'll get a cab for you right now. And we'll send you off in it as soon as possible. Yeah. So at that point in time, we just had a very old Swift Desire. So that artist manager was like, it's fine. I'll sit in this also. It's fine with me. Main baith jaoga. But like, if it's fine with you, you can go in that, right? You go. Then me and Akshay, we came later on after a while in an Innova. And that design didn't, go that fast. So obviously they stopped after a while.
Yeah.
And he came into the Innova.
Yeah.
And then they sped up the Innova as much as they can.
Yeah.
And he even called the Maybach to and were like, slow down a bit. So that the artist manager, he reaches before Shreya.
Yeah.
And we can set up everything for her over there. Right. So yeah, that was pretty fun. And we were so happy just seeing that Maybach pass by. Like, yes, we finally did it. It was very fun.
No, anything else in the department that you work at?
Anything else? So in Dope, I've done a lot of management of inventory and stuff. So for that, in secondary, I didn't take that much initiative then.
I mean, you had busy with
I was busy with SEDS and JNS. Even during Pearl.
Yeah.
So we have Dope room, right?
Yeah.
We have one of the rooms occupied by Dope. So even when I was sitting over there, I used to work on the CanSat design and stuff. And people were like, what are you even here? I was like explaining to them, I'm working on CanSat and everything. Like pretty cool. So keep it on.
I mean, if you just look at someone working on their laptop, doing some 3D modeling on, it looks complicated.
It's just, everyone is just talking and chilling.
Exactly.
I was stressed out in one corner. That how will I get through with this? How will I print this in time and stuff?
Yeah.
How will this mechanism work out?
It's sorry, I'm going back to said JNS a little bit.
Yeah.
But are there like designs that you come up with, but they're not printable, so you have to scrap them as which way?
Yeah, that has happened as well.
So kya hota hai? What was? Do you remember what happened?
So last year release mechanism, I had to edit it a lot so that it is printable. So mainly what I had done was that release mechanism was working
So the castle was
well.
yeah.
I wanted to implement it in the CanSat, right?
Yeah.
I didn't want to, put in that effort to think of another mechanism. So I figured out a way to implement it. I modified it a lot and stuff.
Got it.
And what used to happen was that at that point in time, the Splashforge printer, it sort of malfunctioned.
Oh.
So we just had this Ender printer to work with. And that Ender printer, it stopped a lot in the middle.
Yeah.
And it was pretty slow as well. And the issue with our campus is that whenever there is rain or stuff, there's a power cut.
So if
there's a power cut, the whole print has to be scrapped.
Wow.
And at that point in time, that print used to take about 48 hours on that printer.
Bro.
If I wanted it done on that printer, on Flashforge, it would have taken about 24 hours at most.
Wow. So that's a lot of things.
Yeah. And the funny part was that whenever half of the print is done, it is mainly supports. Because on that release mechanism plate, I used to attach the pitter tube at the bottom because we wanted the pitter tube to be as much at the bottom as we can keep it. So what happened was that plate, it will go into the nose cone, right? And we wanted that pitter tube to extend a bit out of the nose cone.
Correct.
So that it can calculate the airspeed efficiently. So yeah, I had to extend it a lot. So there were a lot of supports.
Wait, so I kind of lost track a little bit. So the pitot tube for the measurement of the velocity of the air, uske liye you have to get it out a little bit, so it put a lot of supports in, and that was difficult.
नहीं, so उसका जो माउंट होता था वो बहुत नीचे होता था प्लीज में, तो उधर कुछ मेजर कुछ और प्रिंट नहीं हो रहा है, सिर्फ वो माउंट ही है इतना नीचे अदर, और बाकी सब चीजें इधर ऊपर, तो फिर नीचे सिर्फ सपोर्ट्स है, राइट, वो तो बाद में निकालना ही है.
Got it. अच्छा, so you have to basically engineer on the solution to do. Okay, fine. Okay, now I get. I didn't understand initially. I think I'll space out a little.
Yeah, no.
But yeah. Anyways, I think that's it, right? Anything else you could cover?
Anything else? Yeah, I mean, in first year I was just very excited to get into a lot of clubs and departments. But I end up making the right decision and getting into the best ones, I think.
Yeah, that's
according to me. So, I mean, everyone has a different preference.
Correct.
Like Ishan, he is also into a lot of good stuff.
Yeah.
He's into PU. He's into Dopey.
Correct.
So, whatever rose his boat. Correct. So, according to me, this was the best thing.
I mean, it seems like it's up your alley, right? You've done a great work structures, and like, bro, the confidence with which you said, ki, kuch bhi raam mein bana looga, print hoga, figure out to do. That is what I want to see. Ki, yaar, the people doing dope shit in college it really makes me happy. Yeah. So, was something like a bahut issue. That was a highlight of my for this conversation. But yeah, like crazy stuff happening with Janus and the SEDS, and I just want all of this to continue. If we can just keep getting those step changes, I think bahut baza hai. And like when you come back to it, maybe
I mean, who knows? Sometime in the future, when Janus turns up to be a startup company, that's all. Who knows?
Crazy stuff. Wow.
One of our professors actually suggested that.
Yeah.
That you expand it and make it that much better that Janus turns out to be a startup or something.
Wow, bros, imagine. But then you could have like
Anyways, Bitsons are known for startups, right?
correct.
Yeah.
Wow. Is that, I mean, will it write in your tenure? Possible है? बिल्कुल possible नहीं.
I don't know. I don't think so. I'll see. I'll try maybe, right?
Yeah, I mean, maybe in your 4th year because you could be like, कर लो यार, कुछ नहीं होता.
Yeah. कर लो यार.
Anyways, still, thank you so much again.
Yeah, thank you for having me.
Actually, I met a senior, a master student. He's working on this thing called like I think they call it wrap something.
Yeah.
So basically, some filaments, अगर for moisture रहता है, so you can't do very precision printing apparently.
Okay.
So he basically developed like this next thing you put next to your printer,
Yes.
and then it basically uses heat and like how it's basically exhausts it, and it evaporates all the water or basically gets the correct moisture content.
So what exactly happens with the filaments is that if it absorbs too much moisture, then it becomes brittle. We aren't able to print with it.
Oh, so that's why it's very important to get the moisture. Like, oh, I don't know.
And filaments like PLA, which are the most easier filaments to deal with, they absorb a lot of moisture.
Oh, so this is what
issue.
damn. So do you guys have to deal with that if it happens? It's fine, the moisture one.
I mean, during monsoon, it's obviously a big issue.
Yeah.
But often what we do is that we just open up the filament. We try and finish up all the prints that we have to give, and that come in week.
Oh, okay.
Otherwise, we keep it up in this locked up cupboard. And they actually provide us that silica gel packet. So we keep that in the packet and we keep it with the filament. So it helps a bit, not much. It's not exactly the most efficient way.
But still.
Yeah, it's
Bro, I did not know you guys had to actually deal with that now also. Oh, super interesting.